Hello, you're welcome to this lesson. My name is Comhendo Allen, and I'm here to present about states of matter and changes of states of matter. In this topic, we shall look at the different subtopics. We shall look at the definition of states of matter. We shall look at the states of matter themselves. We shall look at the characteristics of states of matter, the evidence of existence of particles in states of matter, and the heating and cooling curve. So, matter is anything that occupies space and has mass. Matter is all around us. Matter includes buildings, liquids such as water, trees, stones, even air itself. Matter is in form of states. A state is a distinct physical form in which matter can take in a given environment. States of matter include liquid state, gaseous state, and solid state. However, in extreme environments such as too much coldness or too much heat exposed to matter, states of matter such as plasma, base S.1 condensate, and neutron stars can exist. The major states of matter, that is to say solids, liquid, and gases, have various characteristics. The characteristics of solids as a state of matter are: solids have a fixed shape, they have a defined volume, they cannot be compressed, their particles are closely packed, and they have very strong intermolecular forces of attraction. Now, for the sake of liquids as a state of matter, liquids have a fixed volume, their forces of attraction are moderate, the particles are moderately packed, and then they cannot be compressed. Now, for gases as a state of matter, gases can be compressed, their particles are spaced, they have very weak intermolecular forces of attraction, and they can flow. Now, we ought to know that matter is made up of very tiny particles, and these tiny particles help us to determine the different states of matter as we listed them above there. Matter is made up of particles. The evidence in this case, we are going to use scientific experiments to prove the existence of particles in matter. Now, let's prove the existence of particles in gases. What you need: we need two gas jars, a matchbox, a paper, and a petri dish. Now, what to do? Get one of the gas jars and put it in front of you. Get a matchbox together with a piece of paper and light the piece of paper. As you see, I'm lighting the piece of paper. This piece of paper, put it in the glass jar in front of you, then cover carefully with the petri dish. Invert the second gas jar and put it on top of the gas jar containing smoke from the paper. Now carefully remove the petri dish so that the first and the second gas jars are in contact. Observe carefully what's taking place. As you see, before removing this petri dish, the gas which was in the gas jar was highly concentrated and moving through it randomly. But when we removed the petri dish and inverted this gas just so that they may be in contact, the gas spread through the gas jars from the areas of a higher concentration to the areas of a low concentration by diffusion. Now, this experiment has helped us understand that gases do have particles. Now, the existence of particles in liquids. So now we are going to carry out an experiment to prove the existence of particles in liquids. You should note that liquids involve water. Water is an example of a liquid. So what we need in this experiment, we need 2 glass beakers, we need a few crystals of potassium permanganate and water to act as our liquid. Now, in this experiment, what you need to do, pour 150 ml of water in the second glass beaker. Then put a few crystals of potassium permanganate in the water found in the second glass beaker. Just a few. Leave it for some time and observe what's happening. So now, as you see, the water which was colorless has changed into purple color. It has formed a mixture of purple color. So now our observation is that the crystals of potassium permanganate broke down into tiny particles as they dissolved in the water and spread randomly by diffusion from the areas of higher concentration to the areas of low concentration. So now with this we can conclude that particles do exist in liquids. Now we are going to look at the heating and cooling. We ought to know that the heating and cooling curve refers to the changes occurring to substances as they are being subjected to different conditions. The conditions can be heat or coldness. Now, the heating curve. This curve shows the changes occurring to substances as they are being heated for some time. We ought to know that the heating curve looks like this. Now, for an example of a heating curve of ice at 5 degrees Celsius looks like this. Here at point AB, we get to know that the ice is increasing in temperature. Now, line BC shows us that melting of ice is taking place. Then line CD shows us the temperature of the liquid is increasing. The liquid we are meaning is that melted ice. Now, from there, line DC shows us that the liquid is boiling. Now, if at all we are to go to these regions, with this I'm meaning region P, Q, region R and S. Here, at region P, we get to know that the matter we are having is in a solid state. And region Q, we get to know that after melting, the state of matter is in liquid and solid state. Now, region R, we get to know that the state of matter existing there is liquid only. Now, region S, we get to know that the state of matter existing is gaseous state and liquid state. That's all for the heating curve. Now, if we are to go to the cooling curve, the cooling curve is the curve that shows the changes occurring to a substance as it is being cooled from gaseous state to solid state. Now, we ought to know that a cooling curve looks like this. The cooling curve here, letter A represents that the state of matter existing is a gaseous state. Now, letter AB, this line shows that the state of matter existing is both gas and liquid. That is after the condensation. Now, on line BC, we get to know that the state of matter existing is liquid. Line CD, we get to know that the state of matter existing is liquid and solid. And then lastly, line DE, we get to know that the state of matter existing is solid. Thank you for listening to us, listening to this lesson. Please, may you share and subscribe. May share with your friends and subscribe on this YouTube channel. I remain Commander Allen. Thank you.